Okay, now that we have FOCUST installed, let's go ahead and open it. We can find it in the plugin submenu, all the way at the very bottom. Let me close this log window. I can click on the Help button in order to open up the documentation page for FOCUST. But before we can go ahead and analyze anything, I wanted to show you the optimization window. When it comes to optimizing segmentation parameters, it can be quite tedious to go back and forward, trialing different filters and thresholds and methods, and that got old really quite quickly, especially on 3D datasets. So I built the optimization mode so that you could iterate through a directory of sample images and refine your segmentation in a slightly more interactive fashion. Before we open the optimization mode, let's look at the sample data that I have here. I have two three-dimensional or Z-stack TIFF images. And if I just bump up the brightness so we can see a little bit better, can see that they are 3-channel images and they are indeed 39 stacks. So as we scroll through channel 1, we can see that we have some nice blue nuclei. Channel 2 is a protein of interest. And channel 3 is actin, or representative of the shape of the broader cell. Cool. So let's open up our optimization window and see how FOCUST can lead us towards some kind of segmentation. The first thing we need to do is select our input directory. So I'm going to point FOCUST to this directory that contains my two representative images. The way that FOCUST establishes relationships between segmented outputs from an image will change depending on the analysis mode that you select. I know that I would like to use the single cell mode, and of course details on that are available in the documentation. I know that the single cell mode defines different relationships depending on the objects that we have here. So for single cell mode, the primary objects in FOCUST are the nuclei. So I'm going to leave that as channel 1. I know that the secondary objects are the broader cell. So I'm going to change that to channel 3 for my actin stain. Now, the sort of classical segmentation pipeline usually involves some pre-processing in the form of some filters, selecting a threshold to separate the foreground from the background, and applying some kind of method to separate those thresholded labels. Here in FOCUST, we have many different options for background and foreground filters, a few different options for segmentation method, and quite a few for thresholds. We can configure each of these differently depending on the object type, and we can process them independently so we can look at different outputs from those segmentations. When we click Process, we can also change how our object type is displayed to us. Would we like to see the original channel that we segmented from? And if so, would we like to see that with an overlay of our segmentation as well? I find that can be quite helpful. So first, I know that these images benefit from some background subtraction. So I'm going to run a difference of Gaussian blur. When I select this option, two sets of boxes pop up. The first and the second sigma. A difference of Gaussian blur runs two different Gaussians and subtracts them from each other. Next, I know that I need to add some blur to that difference of Gaussian once it's finished. So I'm going to apply a filter afterwards. Background and filter apply in that order. So whatever background filter runs first, the filter that we select second will be applied afterwards. A lot of images benefit, I find, from running that foreground filter if you're doing some kind of background subtraction. We have several methods for segmenting the objects. I'm going to leave the option here as maxima. Let's go ahead and guesstimate something around sort of size of maybe 7. And we have a number of threshold options here, but I'm going to leave a nice automatic threshold Otsu. Now, I do think that it's quite useful to see the overlay with our segmented output on our original image, so I'm going to tick that box. I then click Process, and we see the segmentation is running. Two windows have now popped up on my screen. On the left, we have a composite image with two channels. the original nuclei channel and the segmented overlay. Let's turn up that brightness a little bit. As I scroll through the Z stack, we can now see that there are nuclei with rings around them. Those rings are the outlines of our segmented objects on the right. I find having those overlays or those outlines makes it easier to zoom in and see if your segmentation has worked quite nicely for those given shapes. Let's say that I'm not 100% happy with this segmentation. I can come back in and I can adjust some of these settings. Let's maybe take this to 5, or maybe 6, somewhere in the middle. And this time, I don't want to see the original image again. I just want to see the segmented output. I hit process, and my segmented output appears. Notice how the windows automatically rearrange themselves. This makes it quite easy to try multiple segmentation parameters, changing all of these different values, process, 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 and then you can view all of these outputs sequentially. This looks pretty good. I'm not upset about this segmentation at all. Cool. Let's have a look at our secondary object. Cool. Let's have a look at our secondary object now. If we select just a straight Gaussian or Gaussian blur, a gentle blur should do, and then maybe a size of 12. Let's try that. And I'm going to keep my automatic threshold. I would also like to see my original Fluorescent stain or broader cell with an overlay, and then let's click process. My windows automatically rearrange, and I'm interested most. My images automatically rearrange, and I'm interested mostly in this top left image. Let's have a look at these segmented outputs. Not too bad, but we can see that there's definitely some over-segmentation of these shapes. As we zoom in, we can see a single shape seems to have been broken up into multiple pieces here and there. Let's go ahead and close these options, and let's increase the size of the shapes we're trying to find. Let's do 16. Reprocess. Let me view our output again. In the bottom left, I can see that that looks much nicer. But maybe we're missing some components to our cells here. It looks like if we zoom in and we turn this brightness up again, looks like we're not capturing a lot of these early cells here with our threshold. So let's go ahead and see how a number of those cells don't have outlines. Let's go ahead and move away from an automatic threshold and try a manual threshold. Greater and smaller constant allow you to define a level at which you would like to keep foreground pixels for your threshold. So when we select greater constant, we can manually specify the value above which we would like to keep pixels. Let's click process. That looks better. So if we now compare on the left our before and on the right hand side here our after, bump up that brightness. We can see already we're getting much nicer attention to detail from some of these cells versus our previous segmentation parameter. If I just scroll slowly through this image, we seem to have found most of our cells, and we're actually getting quite nice outlines on a lot of those shapes, which means that when we come time to analyze them, we're going to be able to detect some pretty cool morphologies that are at play in our particular cell culture here. Great. So I'm happy that these secondary objects are configured appropriately. But what if I want to quickly have a look at what my object relationships might appear as in my data set? When it comes to viewing how your objects are interacting in 3D space and what your segmentations, how they might overlay, we have this Combine Outputs tab. I can specify either filled in labels or outlines of labels and combine them differentially. Say I want to quickly generate a representative image for lab meeting or for a figure for a paper. In this instance, I want to see the full labels of my nuclei and the outlines of my cells. So I'm going to tick labels for primary and outlines for secondary. When I click Update Overlays, I get this new composite image that contains both of my objects specified in the way that I selected the boxes. So we can see some cells here with their solid label nuclei. Now this image is just sitting inside FIJI, so I could go ahead and save this as an animated GIF if I wanted to create a cool scrolling graphic for a presentation, or I could indeed maximum project this to look at the 2D version of the image. We find this feature quite useful. Awesome. Let's say for this particular image, I'm now happy that these segmentation parameters for my primary objects or my nuclei and my secondary objects are looking pretty good. So now ordinarily, I'd need to close all these images and open up my next image and try and remember the parameters that I just applied and see if it looks roughly the same or if I need to tweak something. In this optimization mode, we don't need to do that. Because I've pointed it to a directory of images, I simply click Next, and I move to the next image. All of the images that were open before have closed. But notice my segmentation parameters have stayed the same. So let's go ahead and display my original primary object with its overlay and see what our segmentation parameters give us when we process them on this particular image. Those look roughly nuclei shaped. Let's go ahead and turn up our brightness again so we can have a good look. Segmentation looks not too bad at all. Cool. And what about our secondary objects? We're using the same parameters from our first image. Let's hit process. And much the same outcome. We have nice outlines over all of our cells. Cool. And again, if I wanted to generate the same combined output, I can just hit Update Overlays. And I get a great combination of outlines of cells and solid nuclei. Of course, for each channel, I could customize the lookup tables if I wanted to give my image something creative, or I could save this for later use. If I was to tweak these parameters and decide that in fact I needed to make some adjustments, I can of course navigate back to the first image and see if they still work in that case. What we then wanted to do was have the ability for us to save this configuration. We fully yield that there are a lot of boxes on screen here. We wanted to give some options for configurability. So there are many options on the screen, and it would be very painful if you had to write down all those options manually and then have to re-enter them every time. So in focused optimization mode, we include the option for you to save or load a configuration that you'd previously used. So instead of having to remember all of these parameters, I can click Save Configuration, select a location to save the file, and we end up with an optimization file that's been saved to wherever we specified. If I now close FOCUST, this optimization file contains all of the data that pertains to our particular configuration. And you can view this in any text editor. For example, it contains the path and a record of all of the different parameters used for that segmentation event. If I open FOCUST again and go back to the optimization mode, If I wanted to try the same segmentation parameters on new images I'd captured, or maybe send them to a collaborator, I can simply click Load Configuration, select my optimization file, and open. And all of my data is carried across. This is incredibly useful when you have lots and lots of images that you need to optimize for across different sessions of imaging or indeed different days of analysis. Cool.